And welcome back. Now this is on page 8 of the notes on this chapter. This is on page 8 of the notes of this chapter. This is example 5. Now this is a challenge question. Okay. Now do take note, this one, even though it's a trivial question, but you look at it, there's no triangle given to you. Right? There's no triangle given to you. So they only tell you sine q is square root 45 over 7. So this one calls for some reverse engineering. So what does it mean is, well, we know sine of an angle. This angle, this symbol is called theta. By the way, this is like the algebra, but for angles. This is called theta. Theta. Okay, theta. Now we know sine the angle, sine the marked angle. In this case, Q is opposite over hypotenuse. So what does it mean is I can form this triangle. Okay, I can form this triangle. Sorry, so this one should be Q. So sine Q, my opposite, which is this side, is square root 45. My hypotenuse is 7. So a right angle triangle, I know this is square root 45. I know this is 7. With this, using plus the Pythagoras theorem, I can then find out what is my adjacent here. In this case, I will end up with 2. Basically, 7 square equals to the opposite square plus the adjacent square. Right? So square root 45, I square it, I get 45. Alright, from here, I solve for A, I get 2. The negative 2 can ignore because it is a length. So once I know this, now writing the tangent Q and the cosine Q will be very simple. Tangent Q is basically O over A. So opposite over adjacent. So square root 45 over 2. Right, cosine Q will be adjacent over hypotenuse. So 2 over 7. Right, so this question calls you to form a right angle triangle. Okay, so I draw a right angle triangle first. Okay, mark out the angle. Then I see which length is given to me based on the ratio here. Alright, so this one is one of the challenge question. Now, when we move on to example 6. Now, example 6 is basically more of a real world problem, which is good because it's not that difficult. Okay, it looks harder than it actually is. So over here it says shows an escalator inclined at 28 degree, things like that. Okay, and it says find the value of D. Now basically, if you remove the escalator, all these things, it basically just looks like a right angle triangle. Okay, so the 3 steps to solve remains. Okay, first thing, label the sides. This is the 28 degree. So this is a marked angle. My hypotenuse is here, opposite adjacent. H, O, and A. Okay, then I look at what is given. My A is given. What do I need to find? Hypotenuse. So A and H, adjacent and hypotenuse. Trigo function, which one got adjacent and hypotenuse? The answer is cosine. So I cosine the marked angle is adjacent over hypotenuse, so it's 10 over D. Right, 10 over D. Now, so this one, when I cross multiply and divide both sides by cosine 28, I get this. Okay, so this is under algebraic manipulation, so yeah. Okay, my D will be equals to 10 over cosine 28. Okay, press the calculator. As it is, I will get 11.325. Same thing, I write in phi SF value first. Phi SF truncated, meaning I do not round off. Okay, do not round off, just the first 5 digit, first 5 non-zero digit, and then that's it. Alright, after that I round off to 3SF for the final answer. Okay, then next question, actually nothing to do with trigo, is okay, using this value of D. So this is my distance, my length of the escalator. Alright, they give me the speed, they will ask me for the time. So time is distance over speed. So the distance is the D. So in this case, take note, I use 11.325. Cannot use 11.3. Okay, emphasize again. Cannot use 11.3, have to use 11.325. Okay, divided by the speed given by the question. Press calculator and round off to the nearest second. Okay, as indicated by the question. Okay, nearest second. That's what the question wants. Okay, units for second is just an S, not SEC, just S enough. Right?